All right. So, question number one, what is the DOM? 2 minutes. All right, pencils down. Look at yours, look at mine. Questions?
Straightforward.
Good.
Just said it better.
Yeah.
So, let's see how the internet works. So a key idea that we want to get across here is if I write my HTML So I write some HTML in a text file. I make an HTTP request for it. I get the HTTP response back. This is in the body. Your browser sees it as food and goes, and then poops out the DOM representation of that. So we start with that, and it becomes div p img, and then these have little nodes that go under them. So like text node is how it would represent the inner content of that. We also have attribute nodes for like source is that. So all of the different attributes of a DOM element also are little subnodes of that. And one that I imagine some of you probably didn't include in your answers, but should. These also get style nodes on them that keep track of any all your CSS, your browser CSS, anything that dictates the appearance of this particular thing. And that just goes all the way down. And your browser doesn't understand this. It knows this well enough to turn it into that, but that's it. Once it has this tree, it knows how to visually represent that on the page. Other questions about what the DOM is? And then obviously we can use JavaScript through like the document object to access this stuff, change the nodes, add nodes, remove nodes, and then there's a whole system for how events move through that tree also. Cool. Describe the HTTP request response cycle. 2 minutes. Cool. Look at yours, look at mine. Note the differences. Stuff that you left out. Questions?
Well, I was mistaken. I said a user, but I see where you sort of defined client rather than user because it doesn't have to be a user. Your program can be a client, your browser, there are lots of things that can be clients without actually needing a user interface.
Correct. So a client is just somebody who makes a request. A server is just somebody who fulfills it. Clients can be browsers, they can be servers. So if I make my my HTTP request to a Rails server, and that Rails server makes an HTTP request to the Pokemon API, that Rails server was a server to me, the browser, and a client to the Pokemon API. Key idea in this is that it's two-way, or it's a request and a response. You need both of them for it to be complete. That's not the case with every protocol. For example, HTTP is built on top of a technology called TCP. Who knows what a WebSocket is? give me a description of WebSockets. WebSockets are another web technology that is for two-way communication. A server can't send a response unless it got a request. But what if I wanted to send a particular client a response, but they didn't know they were supposed to ask for something? Think about chat. How do you know that somebody posted a new message? So sockets are a way to, come on. Sockets are a way where your server can actually initiate a message to a client, even if it didn't ask for one.
It would be considered a request?
No, because it's still the server.
Yeah.
It's still providing the information, but your client didn't necessarily ask for it. What your client did up front was established a connection with this server and said, cool, now that we have this connection, I can send you a message anytime I want to, and you can send me a message anytime you want to. But these are one direction. There's no cycle to it. So like the canonical easy example of sockets is any kind of chat. I send you a message, I get notified whenever somebody else sends a message, but I didn't go, hey, did anybody send me a message? Request. Why, yes, here's 3 of them, response. That would be the HTTP request response cycle. If we can just send each other information arbitrarily, that's sockets. And sockets are with a level below HTTP. So if this whole big cycle is HTTP, the trip here was a TCP request. The trip back here was also a TCP request. That's how we transported that request here. HTTP requires a request and response. TCP's dumber than that. It has no clue what's happening with any of this. It just sends information somewhere. Sockets use TCP directly. There's other protocols too that don't cycle. Ones that you guys probably use regularly. UDP. UDP is, I would say, as robust as HTTP, kind of at the same level, but does not expect a response. This is really useful with something like real-time gaming or gaming with somebody on the internet. If I'm using HTTP for that, before I can figure out where somebody is on the map, I not only need to send a message to the server that I moved or whatever, but I also need to wait for that to come back before it can update. If I'm trying to do this 60 times a second, ouch, that sucks. It's too slow. So instead, I can send a datagram, that's the universal datagram packet, I think, that kind of works the same way but does not accept a response. The trade-off is that it might get lost. I have no clue whether or not it got it, and so I'll drop a frame. But I'd rather drop a frame than have my game just work slowly across the board. Another thing that uses either this or a similar technology, streaming video. Too fucking slow. If every single frame of the movie is a separate HTTP request, or it can just push packets at me, and some of them might get dropped, lost. Who gives a shit? It skips, but it doesn't either start the entire thing over, which is what would happen if the entire video was one HTTP request, or slow down because it needs confirmation for every single thing to do the whole cycle. Websites, though, good old HTTP, need the entire cycle for it to work. Any other questions about request response cycle?
So how did technology move from like, or the internet, how did it move from like only doing HTTP requests to doing stuff like UDP? Like did someone just figure out how to make it work?
That's a great question. And it has a lot to do with what this next question is. That having two computers send messages to each other, like, that predates the web by a substantial amount. And is also still used for things that you probably wouldn't just describe as the web. It's just two computers sending each other messages. So we have all kinds of different protocols for that are better suited for one thing or another. And sometimes those get promoted to the big leagues and brought into the web because they happen to be useful for web things also. Other questions about request response cycle? Yeah, Carl.
For the WebSockets,
Mm-hmm.
the connection is started by TCP, and then the responses, and like, say it's in a chat, those are also TCP inside the chat?
So,
Or the
forgive me if I'm inaccurate on this. I'm going off the dome. I'm fairly sure it starts actually with an HTTP request. And I feel like it's a request to establish a socket connection.
Okay.
And I think the response that you get back is data on how that, like, your essentially terms of agreement on how you're going to communicate with each other.
Sure.
And once you get that, you can send TCP messages on that socket.
Okay.
But it's like, okay, cool. Make sure you send everything over to this port, and I'll be listening on that. And I'm going to sign the things that I send you with this thing. I'm almost positive that initial request happens over HTTP.
Okay.
Another thing that might be of interest, this is pure trivia, but I think it's kind of interesting. We had chat on the web before WebSockets were really a thing. And the way we did it is with HTTP with a trick called long polling. I think this is so fucking clever.
Oh.
So the way that long polling works is you take advantage of that timeout mechanism in HTTP. All right, this is client, this is server. I send you an HTTP request, and let's say my timeout is 60 seconds, 300 seconds, whatever. Instead of immediately fulfilling that, I just wait. I wait until there's something to send back. And so nothing's happening. It times out, and as soon as it times out, I just send another one. And then I wait. Oh, cool, there's a new thing to send you. I fulfill the HTTP request and then immediately send another one. And then I wait. 80 seconds later, oh, I have something to send you. It's like hacking HTTP to do this exact same thing. It's called long polling. Because you are polling for changes. Any changes? Any changes? Any changes? Any changes? And you're just taking advantage of the fact that you don't have to resolve these immediately. Yeah.
How do you interrupt that, or how do you interrupt that?
What do you mean?
It's always waiting, it's always
Yes.
sending. How do you say, like, forget, they just tell it to stop at some point?
Well, like your client has the option of just not making another request at some point.
Okay, yeah.
Cool. All right, what is the difference between the web and the internet? 2 minutes. Cool. Pencils down. One thing I always kind of go back and forth on when I'm answering this question is whether or not you consider HTTP an internet technology or a web technology. I'm inclined to call it a web technology, but properly speaking, it's probably an internet technology because it's down in protocol land. The reason I think of it as a web technology is I can't imagine any situation outside of the web where you'd use HTTP. So I think it's kind of in between, but I'm sort of curious what the internet says. Is HTTP an internet technology or a web technology? Yeah, HTTP is the protocol used to transmit all data present on the World Wide Web. Transfer data over the web. Protocol that web browsers and web servers use. Language used on the web for information transfer. Yeah, so like, that's why I think of that as a more of a web technology, but it's pretty low level, so kind of right at the connection of those two things. What questions have you about web versus internet? Yeah.
So I had trouble like going back to the mod where we were going over this.
Uh-huh.
Why didn't you call the network a network of networks? Because for some reason I thought it was a connection of servers.
So server is more of a web idea than an internet idea. So I'm so glad you asked about that because I really wanted to talk about it. So let's say I've got a network of computers in this room. It's got 3 computers. They are hardwired together. And so that's a network. And then I have this access point here that's the router for the building. And its address is 12.0.1.121. Cool. Now, the hub 2 also has an IP address, and it's 122. And behind that is a group of people just like us. And they have their own network. And we've got some more of these. So these things make a network. And by network, I mean just like we can all send each other data, we can also send these computers data and these computers data. So not even talking about web pages or servers or anything like that. Let's just say we can talk to each other. Okay? Now, here's where this gets fucked up. So, even right now, we have a network of networks. Where this gets insane is that this network talks to other networks. So let's say there's one great big loop that's kind of connecting all of this in Denver. Cool. This one is Colorado. And it has these kind of big clusters of networks that talk to each other via these big fat fucking fiber optic lines. And then each of those is a network. And Colorado talks with the rest of the Southwest, and then that's a network in the United States, or different regions of the United States, and the United States, and then the world. And so it's like a fractal. All of these things are networks of networks, and the powerful idea is this computer can get something from this computer. That's what makes it an internet. Let's see if I can get a picture of, let's see, internet backbones, United States. See if there's a picture of it. There we go. That's a map of the physical wiring of the internet in the United States. Isn't that fucking wild? Another way of looking at this. This is one of my favorite images on the internet. Map of the internet.
That one's pretty old at this point.
It is. So that's a map of the internet. Oh, it doesn't have the key on it. I don't think it's high enough resolution to zoom in all the way. I'll find one with a key. The little breakout box that kind of makes your stomach sink. Map. Map of the internet IP addresses. There it is. Let's see if I can. Oh, come on, jerk. Okay, so that same diagram, each one of these little points on here is an IP address. It shows how they're connected. Isn't that wild? Network, 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 network. I mean, it actually looks like a brain. That's what a neural network looks like. Except for all these like highly isolated places like that. That's probably like government shit. Oh, I think that is so cool. Cool. Yeah, Carl.
So, could you call the whole, like the large scope of the internet? Or
Correct.
could you just drop a circle on any point like that's and internet?
Yeah. So, I remember like back when George W. Bush was president and he said internets and everyone made fun of him. And then there was like this weird, like, well, actually part of the internet community is like, well, technically he's correct. And it's because of that. Any network of networks is an internet, but the capital I internet is all of it.
When would you use intra?
Oh, good question. Anybody know? Internet versus intranet?
And it's disconnected from this?
Exactly. Well, the dark web is an internet that's disconnected from this. An intranet is something that you would use like the internet, as in like you type things into a browser and go to web pages and there's links and all that kind of stuff, except it generally either never leaves a building or a company or something like that.
Private?
Exactly.
I guess, okay.
A private internet would be an intranet.
Okay.
Yeah. Question, Parker? Ask me a question. Let me make it less confusing.
I mean, it's just like, really changes my perspective on stuff.
Oh yeah. This will make you more confused, so I'm sorry, but not really because it's fucking cool. So these are called backbones. They're like the big loops, and they're owned by people. There's like companies that own this backbone and this backbone and this backbone, and the reason that traffic can go from one backbone to another is a thing called peering agreements. This is the one that I grew up with. So the person who owns this backbone's traffic is treated equally to traffic on this backbone. The thing that enforces that is a gentleman's agreement. There is like no law. There's really nothing other than like, well, I suppose it's to everybody's benefit if like we treat each other's traffic equally. But there was a point in time where like two of the backbone providers or maintainers like got in a fight and would no longer accept each other's traffic. And that broke the internet for like a while. And like, I think it was before stuff like that got a ton of like detailed coverage in the news. But yeah, they were like, oh, never mind, I'm not taking your traffic anymore. And now you can no longer talk to any computer on this network. So if your fucking data center was located in Arizona and you lived in Seattle, sorry.
There's still nothing governing that?
The internet is held together with tin can wires and like big-hearted ideas.
Oh my goodness.
That'd be a mess to like break apart and be like, okay, I'm not gonna.
Well, that's the kind of the thing. The reason that it got as powerful as it is because it wasn't really regulated. That allowed a proliferation of really powerful, cool things that, like, if there was somebody keeping track of this, they would have never allowed it. But now we find ourselves in this precarious situation where it's tin can wires and gum. Yeah.
What city is that little node that's kind of all along, just around Illinois?
Chicago.
Is it?
Yeah.
Oh, poor guy.
Whoopsie daisy. Oh, this is a really good visualization of it. So yeah, the backbone is up here, and it shows how all the individual computers are connecting to those nodes in the backbone.
What is backbone?
Backbone is like a larger structural piece of the network. So if
More fiber optic, more
Right.
Physical.
bandwidth, more.
Right, so if we say that, like, let's say we just look at this part of it. This is a network, this is a network, this is a network, and they're connected by a backbone. Like, physically, it's just a big fucking chunk of cable. But it's how this network talks to this network.
I could connect to Cat5 cable to your computer, we could send stuff back and forth and never reach the limit. But a city needs way more cable, probably multiple cables, fatter cables, fiber optic.
And they need to upgrade them. And, like, the reason they're owned by companies is, like, they need to get upgraded, they need to get maintained. People either maliciously or not, like, break them. And so somebody's got to take care of that. There's a real big fat fucker that goes from like New York to London, I think, which is like how the United States connects to Europe on this transatlantic cable. Yeah.
Yes, there's literally just a wire sitting in the ocean.
Um,
Something bites it, trips over it.
Which happened. There was like some predator or something like chewed to a transatlantic cable. Like at some point.
Oh, I swear I looked up a documentary like on the first telegraph.
Yeah.
And there's like a wire hanging off the back of the boat.
Yep.
And then
Yeah, they're just throwing it in the water.
They're like, be careful, if it sinks, nobody will get caught on anything.
It's like, it's clad now, but it wasn't once upon a time. For all the fucking magic around the internet, at some point it's just some copper fucking wire, and it pulls pulses, and then we turn those pulses into ones and zeros. And those ones and zeros turn into this, turn into this, turn into this, turn into this. It's all it is. Beeps and boops, baby. Other questions about web versus internet?
So it's like people say that we don't understand like our brains or whatever.
Mm-hmm.
But then the internet seems like very similar, and like the elements that are in it.
Mm-hmm. Absolutely.
Uh,
That's not an accident, by the way. Like, the structure of that was almost definitely inspired by the structure of neural networks. And this is the case in a lot of like engineering sorts of tasks. One of the first questions you should ask yourself when you're trying to figure out how to solve a problem is there something similar in nature? Because nature got a lot of time to think about it and came up with that solution. So there's a lot of times you can pinch and borrow from that, and networks of networks, I think, were a direct result of that. Facebook's Graph API, which is how they manage like that super complex network of recommendations and that kind of shit. How they can predict what an answer to a question that you type in is going to be. They do that by modeling it off of like your brain, basically. But what if all of us were one cell in that brain? Use a similar kind of thing. I know this is Tangent City, but that's also a way that they have better understood disease vectors, like how like computer viruses spread. Has actually given researchers a lot of insight into how actual viruses spread. Cool. What else?
Should do a question in one of these days, like what is a computer virus? Or what is
Ooh. Sure. So lots of different kinds of them. I'll put a minute on this one. Give it your best shot. Broad overview. What is a computer virus? Go. Cool. That was my answer. So I mentioned there were a few different kinds. So something like a Trojan. Trojan horse is, I want to install Candy Crush, and I get Candy Crush. I also get something that was also packaged along with Candy Crush. So you'll see this sometimes on open source sites, where if I go to Ubuntu.com and I want to, it's not community download, there we go. And I want to install Ubuntu Desktop. And I go to download, and it says verify my download. So I have this ISO. I can download it. Cool. What this is saying is if I hash the thing that I get, the result I get should look like that. If it's not, somebody adds something to it. It was Trojaned. And can you think of a better way to distribute a bunch of fucking malicious code? Is like, hey, here's this thing you want for free. Look how generous I am. So we've got things like that. What other kinds of like virusy things can you think of?
Keyloggers.
Keyloggers. So shit like that, that's easy, man. So this is unintended access to data. I have not actually changed the normal execution of your code, so you don't even know that it's doing this. But every time you type something, I also send a little HTTP request to myself, or a server that I own. Or even better, a server that sends something to a server that sends something to a server that sends something to a server, so you can't really track where it's going. At some point, you don't have access to that. And even if you got all of these different organizations to open up their logs of where these requests went, like, I can kind of make that go in a circle. I can obfuscate it in a ton of fucking different ways. And now, I can see everything you typed while you were on that page. Whew.
Is it possible for it to be unintentional?
Yes.
Because I
Yes, it
can
is.
just see someone accidentally, unintentionally, like I said.
Well, like that in particular, that's hard.
Virus or a bug then? Like
Right.
unintentional.
Right. I think that like for something to be a virus, it kind of has to be malicious. But yeah, you can do a lot of virus-like things by accident. You could have, like, I think a more traditional virus would be something that just starts corrupting parts of the code over time. Or, and this is exactly why I tell you guys not to sudo install npm packages. If you sudo install something, it has like root access to your computer. If you happen to also have an npm package that got compromised, somebody accepted pull requests they should not have, it's got a keylogger in it, it's got whatever, guess what? I can sudo rmrf root your entire computer, and you gave me permission to do it. So that's why we don't install strange shit from the internet and then give it root permissions to our computer. Linux and Mac OS are a lot better at that by default than Windows is. Windows got better a few years ago. That's why, like, whenever you install something, it's like, "Are you sure?" But yeah, that's why your parents' computers don't work. Free. I like the sound of that price. All right, cool. Anything else you guys want to talk about before we bounce? Hopefully we're a little bit better at talking tech. Bangarang. Thank you.